So I got some mentions that the last area underneath the curve problem was a bit too easy. Well, okay, let's step it up. We also got a 10 marker, similar to last time, but this time it uses exponentials, and we gotta figure out the shaded region inside of the curve. In this case, the area is going to be the area of the 6 minus e to the x over 2, the blue region, minus the area of the red region, e to the x. In the problem, I kind of confused the color coding, but just know it's the integral of 6 minus e to the x over 2 minus the integral of e to the x. Well, that's great, but what are the limits? Well, one of them is easy, being 0, but the other one is the point where these two curves intersect. So to solve that, you need to make the two equations equal to each other. In this case, it's e to the x and 6 minus e to the x over 2. Doing so will give you e to the x over 2 plus e to the x minus 6 is equal to 0. Now, in this case, it might be a bit evident, but whenever you have three terms and they're all equal to 0, there is a high chance you need to solve for a quadratic. And this is no exception, because if you make a notation of y is equal to x over 2, you can then rewrite the original expression as y squared plus y minus 6. The reason that e to the x is y squared is because if you multiply e to the x over 2 by itself, from indices, you should know that it will be e to the x. So solve for the quadratic and you will get two answers, one being y is equal to 2 and the other one is y is equal to minus 3. The negative 3 cannot be used as the exponential cannot be turned negative, so we focus on y is equal to 2, giving you an answer for x as 2 ln 2 being our limit. So now, take the integral of 6x minus e to the x over 2 between 2 ln and 2 and 0 and take away from the integral of e to the x with limits between 2 ln, 2 and 0. Be careful not to differentiate instead of integrate, because that can happen more often than you think. I'd say do each integral one at a time to avoid making errors, as inserting 0 does not lead to the other part of the limit being equal to 0. Solving this gives you 12 ln 2 minus 2 for the first integral and minus 3 for the second one, giving you a combined 12 ln 2 minus 5. But that isn't the answer. You need to do one final step, which is to break down 12 into 2 times 6 ln 2 and bring the 2 as a power of 2, making that 6 ln 4 minus 5 as requested. Was that also a bit easy? Yeah, maybe, but I do make the